India is building its future on steel and concrete, and the Mumbai-Ahmedabad high-speed rail corridor is proof of that ambition. Within this transformational project, Contract Package C5 is one of its most defining stretches and a tranquil path of bullet train emerging amidst the urban bustle of Vadodara. An 8.239-kilometer alignment running through the living heart of Vadodara city, from the Vishwamitra river crossing in the north down to Chhani in the south, passing through the city's own high-speed rail station along the way. This is not open land. This is a functioning city, dense, active, and constantly moving around us. The alignment threads through established neighborhoods, over active Indian Railways lines, and through urban infrastructure that could not be paused, relocated, or compromised. Every decision on this package had to account for the city on all sides and the railway beneath. From piling within the Vishwamitra riverbed to re-engineering foundation designs from Shinso piles to BCIS piles. From navigating utility diversions and urban encroachments to building over one of India's busiest railway networks, Contract Package C5 has redefined what urban infrastructure delivery looks like. Each kilometer of this corridor is a story of precision, adaptability, and resolve. At the heart of Vadodara, the bullet train station stands as a testament to urban connectivity. Its strategic location provides easy access to various modes of transport, enhancing travel efficiency. Spanning 432 meters, the station is envisioned with a Banyan-inspired architectural design, symbolizing strength, rootedness, and modernity. Line 8 was one of the project's most critical stretches, with work required to be executed within strict stipulated timelines. Located adjacent to the cement yard along the project alignment, N1 and N2 formed key sections of this critical corridor, where the MAHSR alignment passes between the live tracks of Indian Railways. Executing construction activities in such a high-risk zone demanded exceptional safety measures, precise planning, and careful coordination. Delivering this segment with safety, caution, and accuracy stood as one of the greatest engineering and operational challenges for the MAHSR C5 project. This is the environment in which Contract Package C5 is being delivered by Larsen & Toubro for NHRCL, the National High-Speed Rail Corporation Limited. What you are about to witness is one of the most critical construction achievement of MAHSR C5, the Instrumented Railway Portal or IR Portal. It is a cast-in-situ reinforced concrete structure built directly over the active Indian Railways corridor, carrying the high-speed rail viaduct across the existing railway network. Before any work could begin above the railway corridor, the ground clearance along with barricading had to be carried out. Later, the trestle towers had to be established, standing between 12 meters to 14 meters height. These steel support structures the temporary elevated platform on which the entire portal casting sequence rests. The sequence begins with the erection of the main structural steel beams, the backbone of the entire portal framework. Each beam spans up to 26.9 meters and weighs 40 metric tons. They are lifted by 700-ton cranes, with capacity strictly limited to 66% of rated load as mandated by Indian Railways for operations over live corridors during railway blocks. The beams are seated atop trestle towers standing 12 to 14 meters above rail level and verified for level and alignment before any further work proceeds. The soffit panels, the bottom shuttering, are next. Each panel measures 26.2 meters by 4.2 meters and weighs 17 metric tons, lifted with a 12-ton strong back to ensure a balanced, controlled placement. Together, the panels form a continuous shuttering surface spanning the full width of the portal, suspended above the railway corridor below. These panels are erected during railway blocks. Pre-assembled reinforcement cages, each measuring 24 meters in length, 4 meters wide and 4 meters deep, at a total weight of 42 metric tons, are lifted into position within the formwork using 700 metric ton crane. A 12-ton strong back supports the lift. Cages are assembled at ground level by design, so the block window is used purely for the lift and placement. Later, the rebars on either ends of the pre-assembled rebar cage are tied in situ over the erected soffit during non-block period, followed by profiling works. The side shutters are now fixed to close the formwork on all faces. 6 side panels at 9 meters by 4 meters, 2 panels at 9.5 meters by 4 meters, and 2 end shutters at 4 meters by 4 meters, with a combined weight of approximately 23.5 metric tons, are positioned and secured by teams working at height on the beam platform. Full alignment and a sealed formwork system are verified before any concreting begins. Concreting is the most time-critical activity in the sequence. A total of 592 cubic meters of concrete is placed per portal, using 43-meter boom placers, 2 primary units with 2 on standby. The pour rate of 30 cubic meters per hour is maintained to control beam deflection, and the operation is continuous and is done without railway blocks. Teams advance simultaneously from both ends, with ongoing quality checks and temperature monitoring throughout. Backup equipment stands ready because no interruption can be permitted once the pour begins. Once the concrete achieves the required strength, confirmed through cube testing, de-shuttering begins. The side panels and end shutters are carefully removed, revealing the completed portal beam. Permanent, monolithic, spanning 37 meters above the railway corridor. The curing compound is applied on the surface of the portal beam once the de-shuttering is done. Later, the post-tensioning works are carried out in non-block period. Parallelly, the trestles are erected for skidding of soffit. The soffit beam assembly is slid laterally to disengage from beneath the completed portal deck. This is a controlled, incremental operation. Clearances from the concrete above and the railway infrastructure below are confirmed at every stage before movement continues. The soffit shutter panels are dismantled and lowered to ground level, each handled with the same care on removal as during installation. The primary structural steel beams are removed from the corridor following the dismantling of the soffit panels during the railway block period. Subsequently, the skidding trestles are taken down, and once they are extracted, the railway envelope is completely restored. Required clearances are verified. The IR portal then stands fully completed and permanent, supporting the future above the existing corridor.
What you have seen is a construction sequence. What you have not seen is the invisible framework of constraints within which every single step had to be executed. The railway lines below carry 25,000-volt overhead traction live at all times. No person, no equipment, no lifted component was permitted within 3 meters of the railway line. Every lift was planned around this boundary. Every crane radius, every swing path, every worker position was governed by it. Work above the live corridor was only permitted during sanctioned block windows, pre-approved, time-bound periods during which train movement was fully suspended. During the block, the line was ours. The moment the block ended, all portal and above-track work stopped immediately, without exception. Trains then resumed movement, restricted to 45 kilometers per hour as a precautionary measure. The line dictated our schedule, and our schedule was built entirely around it. And above it all, 700-ton cranes operating at a hard limit of 66% of rated capacity. Heavy structures lifted with precision over live infrastructure within hours. This was the operating reality of every phase. Key hazards and risks for each activity were identified and documented along with appropriate control measures. A shift-wise execution plan was developed, supported by a clear responsibility matrix for all personnel involved. Comprehensive training sessions and workshops were conducted before the commencement of work to ensure that every individual, including workmen, understood each stage of the activity and the associated safety precautions. Permit-to-work systems were strictly enforced, and lifting plans, along with relevant permits, were reviewed on a daily basis. 37-meter spans, built above a live railway, delivered within block windows, complying all safety measures. Formwork erected, concrete poured, stripped, and the corridor handed back, all within a framework designed around the railway's own operational demands. What stands above that railway line today is not only the result of engineering and equipment, it is the result of people. The collective effort of every L&T team on this package, those who planned each block down to the hour, those who executed each lift and pour on the ground, and those who held the quality and safety line without compromise through every phase. Alongside them, the continuous technical oversight of the TCAP engineers and the active involvement of NHRCL at every stage of the program ensured that standards were not just met, they were upheld. And guiding it all, the project leadership whose decisions and direction shaped how this work was approached, resourced, and delivered. This was not one team's achievement, it was a shared one. The standard is set, and the work continues. We dared and we achieved.